Hi, I'm Atlee. The name of my talk is Code Reflects Life. It's sort of a twist on a little-known phrase called art reflects life. Similarly to how we layer verbal, facial, and primal communications, coding languages stack on top of each other in various stages of translation, all boiling down to zeros and ones. We humans use sound waves and light waves to communicate with the computer, but the computer uses electrical waves, or charges that are in patterns. And actually the simplest form of that pattern is for the computer to determine whether or not there's a charge at all. And that brings us to capacitors and transistors, which are the building block of processors. Capacitors are built with this in mind, where if a capacitor is full with a charge, it represents a 1, and if it has no charge, it represents, what? We know this, right? 0. 0, yes. Yeah, so basically, this is like the hardware thing that's like at the bottom of the zeros and the ones. It's like a light switch, you know, on or off, on or off. And plants and animals actually also hold charges too, like anything that has a dividing membrane and can build up a charge on one side can also transmit an electrical action. And this is the basis of the work by the sound musician called Melise, who harnesses the electrical actions of plants to create music. What I really wanted to impress upon you today is that, beyond just the hardware, code itself, like fundamental concepts in code, also reflect life, the life and experiences of the people who make that code. And so one example is like binary trees. You know, there's a root, there's a branch, there's leaves, also neural networks. Also genetic algorithms, and you can kind of go on, like as you're sitting through coding classes, you're like, okay, all right, like this is, people made this. It reflects our inspirations, but it also reflects our biases. Joy Boal-Lamguining, for her MIT thesis, what she did was uncovered large racial bias and gender bias in AI services from big companies like Microsoft, Amazon, and IBM. And she founded the Algorithmic Justice League to create a world with more ethical and inclusive technology. We need more people like her in coding, right? Yeah, Joy?
Yeah, Joy.
Right? All right. But what about math? Like, isn't code math? Like, students ask me this all the time. They're like, no, I don't like math. And what I say is that, like, yeah, code is, like, not math. It's, like, really not. Like any natural science, there's the part that we observe, and then there is our interpretation, right? Math, like if you choose to interpret the world this way, math is like all around us. Like it's like bodies moving in space, like universal constants, space moving through time. These are things that we can observe, and math is an interpretation of that. Here's my proposition. Okay, this is maybe a controversial proposition. Probably shouldn't dive too deep on this, but yeah, like God is to religion as math is to code. And what I'm trying to say here is that, like, religion, I hope I'm not offending anybody. Religion is our interpretation of God. Like, whether or not you believe in God, if you do believe in God, God is, like, out there, okay? Math is, like, out there. Code is our interpretation of math. Code is fundamentally... Oh, that was a nice slide. Code is fundamentally a language. And in order to learn it, you need to speak it, not just with other computers, but with other coders. Like, you need a community of coders. This is why, like, crying inside, like, Glitch City was so important to me when I joined this place, because I really, really desperately needed a community of coders to speak code with. You need a network, which brings me to my next network programming. Network programming, which is, in my opinion, the most beautiful, and precise reflection of life on Earth. Network programming is all about juggling these different perspectives of life and deciding what is reality. And when I'm doing network programming, I'm usually like, what am I doing? Deciding what is real. Okay, wait a minute, I'm going to explain this. So here we have 3 players, okay, and each of them have a perspective of themselves and a perspective of each other. And what I do, what my job is to send data between them so that they can have a shared reality of the game. And I'm also trying to do this with as little data as possible because I want the game to run as quickly as possible, okay? Networking in a nutshell, in a slide. But what I think is funny when I'm network programming is I'm like, oh, this is like such a reflection of life on Earth, my life right now. Because I'm usually like a little bit anxious that I'm like the only woman engineer on the team. I'm like, oh, why aren't there more women here? Am I not smart? Am I whatever, And I'm trying to negotiate my impressions of my colleagues and their impressions of me with as little data as possible so that we can work together as quickly as possible and effectively as possible. And hang there for a second. So what I learned, like as I'm sitting there being like, what should I say, what should I not say, do they know who I am, my past. I have actually learned something from the very code that I've been working on. And the key thing here about network programming is there's like 2 ways to send messages. It's so beautiful, boiled down that way. UDP and TCP, okay? It doesn't matter what they stand for. UDP is unreliable. This is stuff that you're sending every frame, you're sending all the time. You don't really know if your message arrived, and you don't know what order it arrived in, but it doesn't matter because by the time you're like, oh shit, I lost a message, it's like you just have more messages, so you're like, whatever. And so like UDP, the real world or human corollary to that is chit-chat, like whatever, I'm just at lunch talking about my dreams, and if you missed a part, no big deal. And then there's TCP. TCP is truly reliable, okay? It runs more slowly, but it does that because it's a handshake. Like, you're not going to send the next TCP message until the next computer is like, yo, I got your message, and it's here, And then you're like, okay, you're ready for the next one. TCP is for messages like, my player died. If we miss that one, it's like a real bummer for the whole game. So TCP messages, I've learned to recognize these in myself. They're messages that are happening like if my heart is beating a lot, or I'm like sweating, or I'm starting to like tear up, or like whatever. Like these are, then I'm usually to myself, I'm like, yo, Allie, you're having a TCP message right now? It's so embarrassing. Maybe it's time to like take a break and get some water, go to the bathroom or something, because you can't just send this data. Like, you need to plan how you're going to deliver this message. And the way humans deliver TCP messages, or the way, like, I've really honestly learned how to do this and like thrive in an environment that like I wasn't necessarily going to thrive in. I've learned to deliver these TCP messages that arise in my heart, face-to-face, in private, planning beforehand, in a time when I'm calm and like not afraid, and I can speak honestly with my colleague about whatever happens that set my heart racing that day at work. And this has been really critical. I feel like I am doing my best. Therapy every week, I practice this shit, and I feel like I'm doing my best. And then it's like the ball is really in my colleagues' court, and how they respond to this message. You know, which one is like, yo, I got the message? Which one's the TCP? I'll give you, yeah, it's this one. It's this one. And that one's like, UDP. You know what I mean? So then it's up to them, and like how they respond is really how effectively we're able to code together. So thank you.